Magnetic properties. While electrons are revolving round the nucleus in various orbits, they are also spinning about their own axis. A spinning charge generates a magnetic field. Hence, spinning electrons act like tiny magnets. Any electron orbital can accommodate maximum 2 electrons. If an orbital contains only one electron, then it may spin either clockwise or anti-clockwise. The unbalanced spin exhibit magnetism. However, if the orbital contains 2 electrons, then one electron spins in clockwise direction and the other in anti-clockwise direction, so that spins are balanced and the magnetic property will not be observed. The figure shows spinning motions of electrons clockwise and anti-clockwise and its action like tiny magnets. Paramagnetism. If an atom or a molecule contains more unpaired electrons revolving in their orbitals, the magnetic movements do not cancel each other. There is a net magnetic moment associated with the species, and the species experience net force of attraction when placed in magnetic field. This property of a substance due to the presence of unpaired electrons, due to which substance experiences pull in magnetic field, is called paramagnetism. The extent of paramagnetism present in the substance depends upon the number of unpaired electrons present in the substance. More the number of unpaired electrons in the substance, the stronger is the pull due to paramagnetism of the substance. Oxygen, Cu2+, Fe3+, Cr3+ ions are some examples of paramagnetic substances.
Magnetic substances are:
a paramagnetic substance is feebly attracted by a strong magnet. When placed in a non-uniform magnetic field, these substances move from weaker parts of the field to the stronger parts. For example, when powder of a diamagnetic substance put in a watch glass placed on two pole pieces of magnet in such a way that the magnetic field is strong near the sides of the glass plate, you can see that the material is shifted towards the ends of the plate, where the magnetic field is strong. Similarly, when we bring the two poles close to each other, the material is shifted towards the center, again where the magnetic field is strong. When a specimen of a paramagnetic material is placed in a magnetizing field, the lines of force prefer to pass through the specimen rather than through air. Thus, magnetic induction inside the sample is more than the magnetic intensity. When a rod of paramagnetic substance is suspended freely in a uniform magnetic field, the rod comes to rest with its longest axis along the direction of the applied field, or the shortest axis is perpendicular to the direction of the field. When a paramagnetic liquid, say solution of copper sulfate, in a U-tube is subjected to a magnetic field, the level of a paramagnetic liquid in U-tube rises.
Paramagnetic substances. Let us discuss paramagnetic materials. These materials are weakly attracted by a magnet. When a paramagnetic material is suspended in a uniform magnetic field, The paramagnetic substances rotate so as to bring their longest axis along the direction of the field. When a sample of paramagnetic liquid is put in a U-tube and strong magnetic field is applied across one of the two limbs, the level of liquid rises. This proves the movement of paramagnetic liquid from weaker to stronger parts of the field. When a paramagnetic substance is placed in a magnetic field, the magnetic field lines prefer to pass through the substance. It shows that the magnetic induction inside the sample is greater than the magnetic induction outside the sample. The magnetic susceptibility of paramagnetic substances has a small positive value.